Vicky here at the New Mexico Museum of Natural History with a Pentaceratops. I've come to check out the prehistoric sharks, so I'm super excited, and let's see if I can find a Godzilla shark. Hello! So this is a complete fossil of a prehistoric shark. Now normally, and you might know this, if you're looking for prehistoric sharks, you're gonna find things like these really cool spines or the teeth. And that's about it, because sharks have these cartilaginous skeletons. And what you're looking at is a super big deal.
We're in the collection, the fossil collection of the New Mexico Museum of Natural History and Science, looking at the actual fossil of the Godzilla shark. The fossil was discovered in 2013, and it took about 5 years to prepare it, to clean it. It had to all be done by hand with a needle by somebody, one of our preparators who's extremely skilled at working on these kinds of very delicate fossils.
But there's way more going on with this fossil, and it's really hard to see it all without starting to destroy it. So that's why modern technology is so awesome. They're able to use CT scans to really get in there and see a lot more of the biomechanics that's going on with this head.
But the thing we found out, we got this CT scan. And when it was CT scanned, the lower jaws of the shark are right underneath here, complete, with all the teeth intact. And the reason we CT scanned it was that, practically speaking, we couldn't get to those jaws without removing a lot of this material. And it would have been impossible to do that without damaging some of the skull. So this is a wonderful thing in paleontology now, that we have these kind of, some people call them remote sensing or non-invasive analysis through CT scanning, that allows us to really know what's in the block without damaging this absolutely unique and to us precious fossil that's sitting here.
Is the only complete fossil of a shark in North America. And the only way you get something like this is if you have a really muddy bottom. But if you were in New Mexico 300 million years ago, it was a completely different situation. In fact, it would be like your tropical vacation. This area was actually near the equator, and if you wanted to think of what currently is the closest to it, you're probably thinking about like Southeast Asia. So take yourself back to that time, and that is where you'd be finding the Godzilla shark. The fun doesn't stop there. So this is part of a whole prehistoric ecosystem. It is part of this ancient bay where they have found other animals there. And if you know about sharks, then you know that sharks can get pretty big. But back in the day, this Godzilla shark really earned its name because it was the biggest thing out there. They believe they found evidence of other sharks, but it's this guy that was eating everybody else.
About this is this shark was about 7 feet long, which isn't very big for a shark today. But if you go back 300 million years ago, this was a very big shark. There were not very many of any other sharks that were as big as this thing in the 300 million year old seaways that covered New Mexico. So that's one reason it got the nickname Godzilla shark, because it is a monster. If you were someone who worked on these types of fossils, you would be quite impressed with how big this animal is. Not to mention the fact that so much of it got preserved, because as I think you know, sharks have cartilaginous skeletons. Their skeletons are mostly cartilage. Only the teeth and the denticles have an amyloid or bone in them. So it's very rare to get a nearly and essentially complete skeleton preserved like we did here. And it gives us a remarkable insight into this animal that we don't get from most sharks of its age. And that fossil's in 3 pieces as it was collected and fully prepared. This first piece is the block that contains the skull. Here you see a big part of the brain case. This is a model of a brain case of a somewhat geologically younger and much smaller shark. And you can see the size difference. This is this, This is that. This was a much larger shark. And what you see here is the brain case. There are parts of the gill rakers. There's some denticles and teeth here. Let's go over to this block. This is the biggest block, which I would say is the body. And here, these two huge spines, these are amazing, were in the back of the shark. And if you look at it, you can follow the cartilage along the backbone. You can see that it's kind of been twisted a little. So this is the back of the animal. And then very visible here is the pelvic fin. This is the hind fin of the shark. And what I find amazing is even though this animal is fairly big, these spines are huge. And if you look at the reconstruction, they seem disproportionately large for a shark of this size, but they're here. I think if someone found one of these spines alone, they would have thought it was a much bigger animal than it is. And so I think the spines, of course, are bone and amyloid. But again, everything else you're seeing here, including the fin, that's all cartilage that's been preserved. So finally, we have the third block, and this is the tail. You can see the two lobes of the tail here. They're very clear. And of course, they're all cartilaginous as well.
So this is why New Mexico especially has a lot of really cool fossils and a lot of interesting information that you may not think a marine biologist like myself may be interested in learning more about. But understanding what sharks are like in the present, it's really helpful to see what sharks were like in the past. And so with this Godzilla shark that's even older than Megalodon, you can sort of get the picture of how sharks evolved to what you see today.